So, graphing review before we get into 1-6 solving linear systems. First, standard form of a linear equation is ax plus by equals c. Ax plus by equals c, where a, b, and c are the constants. All right, they're constants. They're only integers, meaning they're not going to be decimals or fractions. Okay, they're not going to be decimals or fractions. That's what integers means. And then x and y are the variables. Okay. So we can go from standard form to slope-intercept form by isolating the y in standard form. Okay, we'd subtract ax and then divide by b. But in slope-intercept form, x and y are still the variables. M is the slope, and b is the y-intercept. Wanted to see if I had changed that. Go there. Don't write that. That's wrong. It should be negative a over b. All right. So, well, you'll see me do these first couple examples. Okay, I'm going to both solve in standard form. All right, and so, I'm going to isolate the y, solve for y to get slope-intercept form. But another way that you can graph out of standard form is you can get the slope from doing negative a over b, which give you that slope of that line, okay? And then you can find the y-intercept by plugging 0 in for x and getting the y-intercept that way, okay? So you have two different options there and how you want to graph. I'm not going to do it both ways every single time, okay? I'll generally just put it in slope-intercept form, but you may do it either way. So for this example here, 2x plus 3y equals 3, I'm going to isolate the y. I'm going to solve for y. So first step there, I'm going to subtract 2x, which gives me 3y equals negative 2x plus 3. And then I'm going to divide by 3 to isolate that y, which would give me y equals negative 2/3 x plus 1. Okay. Y equals negative 2/3 x plus 1. So in slope-intercept form there, my slope is negative 2/3 and my y-intercept is 1. So when our slope is negative 2/3, we want to put that in either the numerator or the denominator. Hold on, I'll get to that in a second, I guess. All right, so next right here, I wanted to show you in standard form right there, 2x plus 3y equals 3. At the top right, we got a is 2, b is 3, c is 3. We're not going to use the c here. But if you were to do negative a over b, that would give you negative 2 over 3, which is the slope we found there. And then if you were to find the y-intercept by plugging in, you'd plug 0 in for x, which that would leave you with 3y equals 3. Divide by 3, and y would give you 1 there. So, again, obviously, same slope, same y-intercept there. Two different ways of doing that, okay? When we have our slope, slope is rise over run, right? Slope is rise over run. Rise in the numerator. If it's negative, we're going down. If it's positive, we're going up. Run, the denominator. If it's negative, we're going left. And if it's positive, we're going right. So, the slope, negative 2/3 there. A mistake I often see is people get confused. Is the negative in the numerator, denominator? Are they both negative? You need to place it in the numerator or the denominator. You need to have it as negative 2/3 or 2 over negative 3. Okay? Negative 2 over 3 or 2 over negative 3. Okay? So that first example would be down 2, right 3. Second example would be up 2, left 3. But that's the same slope. You're just in black, you're going right. In pink right there, the second one, you'd be going to the left. Okay? It's the same slope. You're just going different directions. A common mistake I see here is people say that if the slope is negative 2/3, they do negative 2 over negative 3. All right? That's not right, right? What's a negative over a negative? A positive, okay? Negative 2 over negative 3 is the same slope as 2/3, okay? Do not make that mistake, okay? Don't do it, all right? I'm going to see it on the test, okay? Don't make that mistake. All right, first example here, y equals 1/2 x plus 1. What is the slope of that line? 1/2. What is the y-intercept of that line? 1. Good. Some of you all need to be paying attention and not talking. So, y-intercept, we always plot our y-intercept first. Okay, at 0, 1. We always plot that first. And then from there, we will draw our line using our slope. So in this case, we would be up 1, right 2. Up 1, right 2. Or down 1, left 2. Down 1, left 2. Down 1, left 2. We would have our line. Our second example here, what would be my slope? Negative 1/2. And what would be my y-intercept? 1. Okay. So our first step, we always plot our y-intercept first at 0, 1. Okay? Or in this case, 0, 1. We always plot our y-intercept first. So our slope is negative 1/2. So you can graph that as negative 1 over 2, Luke, or 1 over negative 2. Okay? So for my y-intercept, I'll be down 1, right 2. Down 1, right 2. Or I can go up 1, left 2. Up 1, left 2. And I have my line. All right. Next example here. (2x minus y equals negative 3). Okay? So, it's in standard form. So I'm going to isolate the y. I'm going to solve for y. So first step, I'm going to subtract 2x here. Which give me negative y equals negative 2x minus 3. Then I'm going to divide by negative 1 to get that y by itself. Of y equals 2x plus 3. I could have also done negative a over b, which in this case, a is 2, so that would be a negative 2 over b is negative 1, which again would give me a slope of 2. Negative 2 over negative 1 is 2. And then my y-intercept, I would plug in 0 for x, which would give me negative y equals negative 3. Divide by negative 1. I'd get my y-intercept as 3 there. Okay, again, you can do that either way. All right, I don't care which way you do that. Okay, again, you'll see me. I just like putting it in slope-intercept form. So that's what I'll be doing on the examples, but I'm good either way. So again, we want to mark our y-intercept first at 3. then for our slope, will be up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1. We'll have our line. Do that either way. All right, once you get this down, do that last example there. Do x plus 3y equals 6. All right, so I subtracted x, got 3y equals negative x plus 6 divided by 3, and I got y equals negative 1/3 x plus 2. So y-intercept at 2. And then I'm going to be down 1, right 3, or up 1, left 3. Okay, down 1, right 3, or up 1, left 3. Okay. Questions there? All right, 1-6, solving systems of linear equations notes, okay? So today, first part, we're just going to do the graphing, okay? The back will be substitution elimination. We'll pick that up tomorrow, okay? I guess for y'all Wednesday. All right, we'll pick that up for y'all on Wednesday, okay? So again, we're only going to graph. So systems of linear equations, what we're doing, this first part is we're graphing two lines, okay? All right, they're linear equations, they're lines. We're graphing them, and we're trying to see if there's a point of intersection, like in this example right here, okay? This first example on the sheet, when those two lines were graphed, as you can see, they're in standard form. They put them in slope-intercept form. And then when they graphed those two lines, there was a point of intersection at -3, -3. Okay? So the solution there is -3, -3. The solution is an ordered pair. Okay? The solution is an ordered pair. The point where the two lines intersect. Okay? When that happens, okay, we classify that as consistent and independent. Consistent means there's a solution. Independent means there's one solution, right? Consistent solution, independent, one solution. When you think of the word independent, Xander, what do you think of?
Independent, solution.
Just the word independent.
Yeah, just the word independent. When you think of independent, what do you think of? Hooker, put your hand down.
It's not a trick question.
It's not a trick question.
Can I go now?
Huh?
Can I go now?
Wait, just say something.
Luke, when you think of independent, what do you think of?
Alone, by yourself.
Alone, by yourself. Okay. Like, alone's kind of dark and depressing.
Yeah.
Like, see, like more. I think of independent more like I don't need people to help me. Like I can do this myself, right? Like I'm not like alone, kind of.
Email.
Yeah, that was kind of an emo response, wasn't
I'm
it?
so
That's
use it in a
okay.
sentence. I'm so independent. I don't need a man.
I love that. I love that. That's right.
Not a woman.
Yeah. Well, yeah. Thank you for clarifying.
Yeah, that's
At the
good.
class
I
level.
didn't
All right, so our other options here. All right, we can get consistent dependent. That's infinite solutions. That means the lines are the exact same line. Okay? If you get the exact same line, it's infinite solutions, Emily. If it's the same line, what are the solutions?
I don't know. So I was looking at the
Yeah, I know.
Infinite solutions.
If it's the same line, it's infinite solutions. Okay? And then last, we have inconsistent, no solution. Okay? There's no solution. That means those lines are parallel. Okay? Parallel. There's no solution. The lines are parallel. Okay? Because do parallel lines ever intersect?
No.
No, because they're parallel.
Sure
They're
don't.
Independent.
Sure. No, they're not. They're inconsistent. Okay. All right. So, first example here. We're only going to do 4 of these. Okay? We're going to do 4 of these. So, I know there's not a lot of space. So, you can write all over the bottom right here. So, number 1, both of them are in standard form. I'm going to put them into slope-intercept form. So, first, line there, I'm going to subtract 3x, which gives me y equals negative 3x minus 2. Y equals negative 3x minus 2. My slope is negative 3 over 1. My y-intercept there is 0, negative 2. Ellis, stop talking. So first step, I'm going to plot my y-intercept at 0, negative 2. And then I'm going to be down 3, right 1, or up 3, left 1. Up 3, left 1. And I'll have my line. My second line, 6x plus 2y equals 10. Going to subtract 6x, which leaves me 2y equals negative 6x plus 10. And then I'm going to divide by 2, which gives me y equals negative 3x plus 5. All right. So my slope is negative 3 and my y-intercept is 5. What kind of lines are these lines? Parallel, good.
Do we just like,
So I'll mark
yeah.
my y-intercept at 5. I know that's off, kind of lame. And then we'll be down 3, right 1. Down 3, right 1. Have our line. Probably should have done increments of 2, but I hate doing increments of 2. Just
Thank you for not.
it just doesn't
It's
like
so confusing.
it's not as satisfying. But also going off the graph isn't satisfying either. But
I'd say you do increments of 1 to make the graph bigger.
well, the worksheet had the graph already imprinted on there,
I see.
so and it's a PDF, so I couldn't remove it.
But I would never
We
do
need to
that in the
try a
life.
different provider.
So these solutions, there's no solution there. It's inconsistent. Shh. No solution. Inconsistent. All right, our first line here, we got x plus 2y equals 5. So again, I'm going to solve for y. So I'm going to subtract x. I get 2y equals negative x plus 5. Then I will divide by 2, which gives me y equals negative 1/2 x plus 2.5. Okay, 5 divided by 2 is 2.5. So, first step here, I'm going to mark my y-intercept at 2.5. Mark my y-intercept at 2.5. And then my slope, I'm going to be down 1, right 2. Down 1, right 2. And I'll have my line.
That stinks.
Yeah, I don't like
Fractions are fun.
No, I don't like the decimals. How it's like not in like on a line.
I don't even care about the decimals. I don't like the slashes.
Bro, what?
Fractions?
What?
You mean
What are
fractions?
you talking about?
You
Talking about, like,
prefer
how you
the
write
straight line or the slash? No, I
Fractions,
prefer
you
no
don't
line at all.
All right, second line.
I'm just grinning because I thought it was funny.
So I got 3x minus 15. Did Eden just left?
Here's the back.
Equals negative 6y.
Bother to ask.
All right, 3x minus 15 equals negative 6y. So the y on the right side, we don't need to move. We don't need to swap sides or anything. You can just divide by negative 6 here. We just want to isolate that y, okay? Which that will give me negative 1/2 x plus 2.5 equals y there. So what kind of lines are those?
Whoa, whoa, whoa. They're the same.
They're the same. Good.
Oh.
They're the same. Flexive property, you can flip that over. Same line, all real numbers, consistent, dependent. What we're going to do here. Hey, 2x minus y equals 3. All right, first step here, I'm going to subtract 2x. Which will give me negative y equals negative 2x plus 3.
Wait, I have a question.
Yeah,
Did you skip a problem?
I did.
You did.
Wait.
I did. Shh. Then I'll divide by negative 1, which gives me y equals 2x minus 3. So the slope of that line is 2 over 1. Y-intercept 0, negative 3. All right, because we got 3 minutes left. All right, so first step, mark that y-intercept at 0, negative 3. My slope is up 2, right 1, up 2, right 1, up 2, right 1. I have my line. My second line, all right, I need to isolate the y, so I'm going to subtract x. 2y equals negative x plus 4. Divide by 2. Y equals negative 1/2 x plus 2. So, first step, I mark my y-intercept at 0, 2. And then I'm down 1, right 2. Down 1, right 2. And I have a point of intersection there at 2, 1. My solution is 2, 1. It's not x equals 2, y equals 1. It's an ordered pair. My solution is 2, 1. So that would be consistent and independent.